All right, we are listening. We are not talking. Shh. Guys, taking a look. An event that measures the likelihood that the event occurs on actual results. That is for experimental. Does everybody see that?
Yes. Yeah.
Theoretical, the likelihood of an actual event based on mathematical reasoning. Yes. Okay, we're going to actually go through and work out these problems. All right, let's not get distracted. It was good. Thank you for asking. All right. Shh. Number 1. A baseball. Come on, pick one up. Shh. Make sure it says 13.2 notes. Hey, guys, we can't get that distracted that fast. All right. A baseball player got a hit 21 times on his last 67 times at bat. If he's actually going out there and batting, is this theoretical or experimental? Experimental. He's actually doing it experimental. What is the experimental probability that the player got a hit? Good job. Oh, you know what? I didn't write it down up here. Let's write it down. I'm going to put P parentheses event. That's P stands for probability. The probability of an event happening is favorable out of total. You guys have dealt with probability before, yes? Probability of an event happening is favorable out of total. All right. What is probability that the player got a hit? How many hits did he get? 21. That's a favorable. Out of how many total? 67. You have choices. Leave it as a fraction as long as you reduce. Does 21 over 67 reduce? No. Okay. Or change it to a decimal. Let's do 2 decimal places. Can you guys plug in your calculator? 21 divide by 67. Point or 0 point what? 31. Or a percent. What's 0.31 as a percent? 31%. All right. Question on how you can write your answers. When you're going, yes, when you're going further and they're asking you like questions on part B, this is the easiest one or the best one to use. Technically, you can still use the fraction, you can still use the percent, but the one that's in decimal form will be the quickest. All right. If the player comes up to bat 215 times in a season, about how many hits is he likely to get? Is 215 bigger or smaller than 21? Bigger. So should he have less or more than he should have more, right? All right, so there's different ways of doing this. Yes, Dowda? All right, does anybody have any suggestions on how to do it? Okay, 0.31 or 31%, which eventually you will still change to 0.31 times what? 215. Please stop the talking, guys. Now, I had a kid say, can we set up a proportion? Yes, you can, but this is much easier. 0.31 times 215. Can you guys plug that in your calculator? 66.6. Okay, so let's make a whole number for hits. Approximately how many hits? 67? All right, nearest whole number, that's 67. Do we agree? Please leave them alone. All right, questions. All right, next one. A medical test. A medical study tests a new cough medication on 5,200 people. Is this the favorable or the total? It is effective on 4,182 people. What is the experimental probability that the medicine is effective? So this piece here, is this total or favorable? Favorable. All right, so what is my fraction going to be? Okay. 4182 over 5,200. Can you guys, I'm definitely not going to leave this as a fraction. Change it to a percent. 0.80. which is 80%. And again, you could leave it here. As long as you reduce, since I didn't reduce, I'm not going to circle it. If you do leave it as a fraction, just make sure you reduce. And since both numbers are even, it does reduce. All right. There's another question. You don't have to. Pick one or the other. I like this one, but when I go to answer the second question, I always use the decimal form. All right. Here's the second question. For a group of 9,000 people, predict the approximate number of people to whom the medicine will be effective. Now, Carolina told us on the last one what to do, so I'm going to have someone other than Carolina tell us how to do this one. What do we multiply? Giselle? Good job. The percentage of it working times the 900. If we left it as 80%, do I have to change it to 0.80? Yes. If you write it as percent, you have to change it back to decimal form. All right, plug it in your calculator. How many people? All right, questions? All right, phones put away. You guys are taking notes. Next one, a bag contains letter tiles that spell the name of the state Mississippi. Find the theoretical probability of drawing one tile at random for each of the following. All right. P stands for probability. So what's the probability of drawing an M? 1. How many M's do I have? 1. There's one favorable. Can you count the letters in Mississippi? 11. Now, with fractions like this, I typically leave it in fraction form. You can change it to decimal, but when it's small fractions, I leave it. It's up to you, though, and how you want to write it. All right. Probability of picking out an I. How many I's in Mississippi? 4. 1, 2, 3, 4. So 4 out of 11. All right. The next part is the same thing, Mississippi. What's the probability of getting not an M? How many not M's do I have? Okay. Now, all of you guys can just look and say, well, if there's 11 letters and one of them is an M, then there's 10 that's not an M. Do you guys agree with that? Pretty basic and easy to do in your head. Now, I'm going to give you the formula because they're not always going to be this easy. Please stop. The probability of not Q or not M or not whatever the event is equals 1 minus the probability of Q actually happening. Okay, now you're going to say, well, it's easy to not do the formula, but we're not always going to be easy ones like that one that we just did. So even though it's easy to do without the formula, I'm going to show you how to use the formula so when we're ready, we know how to use it. The probability, this is just an event Q. The probability of not event Q happening is 1 minus the probability that it does happen. So let me show you. For example, if I say there's a 20% chance of it snowing, what's the percent of it not snowing? 80, because 1% or 100, which is 1, minus the 20 or whatever number I gave you is 80. Do you guys see that? Yeah. All right. So let's take a look down here. Even though it's easy to not use the formula, I want to show you how to do it. The probability of not M is 1 minus the probability of M actually happening. That's the formula. Do you agree? Yeah. Yep. Probability of not Q is 1 minus the probability of Q actually happening. The probability of not M is 1 minus the probability of M actually happening. Now we did M earlier. What was it? 1 out of 11. Now the 1 can be written as 5 over 5, 7 over 7, 8 over 8. What am I going to write it as so it's a common denominator? 11. So if this denominator had been 12, let's say it was 1/12, what would I rewrite 1 as? 12 over 12. If this denominator was 7, 1/7, what would I make the 1 out of? 7 out of 7. What's 11 take away 1? 10. Out of 11, and is that the same answer that you got without doing all the work? Okay, why do we do it? To get the practice when it's not so easy. Okay, let's do the other one in our head. How many P's do I have? 2. 11. So how many are not P's? All right, so we know that's the answer. Let's practice the formula. Adam, head up off the desk. The probability of not P is 1 minus the probability of P actually happening. What's the probability of P? How many P's do we have? 2 out of 11. I want my denominator to be the same, so how do I rewrite the 1?
11.
Again, it could be 7 over 7, 9 over 9. Why do we do 11 over 11? Because that's my denominator. What's 11 take away 2? 9 out of 11. Is that what you guys gave me earlier? All right. Questions? Now, on these easier ones, is it okay if you just count the not P's and do 9 out of 11? It is okay. The only reason I show you is so that when we get to the hard ones, you know the formula, you know how to do it. Got it?
Good.
Okay. Next one. Use the spinner at the right to find the theoretical probability. So now I'm not spinning the spinner 100 times. I'm just going to use mathematical reasoning. What's the probability of getting an odd number? How many odd numbers are here?
1, 2,
4.
1, 2, 3, 4. So 4 out of
8.
4 out of 8, which reduces to 1/2 or 0.5 or 50%. I do not need all three. If you write as a fraction, I will mark it wrong if you leave it as 4/8. Why? Because you can reduce. 1/2, 0.5, or 50%. Alrighty. Next one I'm going to change. Probability of not of a number greater than 5. I do want to change that. Please change it on yours.
3.
Okay. Now, if it says greater than 5, do I include the 5?
No.
No. 6, 7, 8. So 3 out of...
3 out of 5.
8.
I'm sorry. 3 out of... Sorry. 3 out of 8. Can I reduce 3/8?
Yeah.
No. You can change it to a decimal if you want. 0.375 or 37.5%, your choice. Again, when they're small fractions, I just leave it. Or if I'm not asked to do anything further, I just leave it as a fraction. All right. Probability it's a prime number. Is 1 prime? Up here, please. What's the definition of prime? A number that's divisible by 1 in itself. Okay, so 1 is prime. Is 2 prime? 2 is prime. It's the only even number that's prime because the only thing that goes into 2 is 1 and 2. Is 3 prime?
Yes.
Is 4?
No.
5?
Yes.
6?
No.
And 7?
Yes.
And 8?
No.
No. So how many?
5 out of 8.
5 out of 8. Can't reduce it. Or 63%. It's your choice. Or 0.63. All right. Questions? A student randomly selected how many vehicles?
65.
This one they told you the number of vehicles. On the test or the quiz or even homework, if they don't tell you, what are you going to do with all these numbers? Add them together. All right. A student randomly selects 65 vehicles in the student parking lot and noted the color of each. She found that 9 were black, 10 were blue, 13 were brown, 7 were green, 12 were red, and 14 were a variety of other colors. What is each experimental probability? Okay, so experimental is, again, she went out there, she counted the cars, she counted how much of each. What's the probability that she gets a blue car?
10 out of 65.
10 out of 65. If you can leave it as a fraction, you do have to reduce. What goes into 10 and 65? 5. 10 divided by 5?
2.
65 divided by 5?
13.
13 is correct. 2/13. I'm going to leave it as a fraction. Got it? How many browns are there?
13.
So what's the probability of getting a brown car?
13 over 65.
13 out of 65, which does reduce. Does anybody know what you can divide by?
13.
13 goes into both of them. What's 13 divided by 13? 1 over 65 divided by 13? 1 over 5.
0.2.
Or 0.2. Or 20%. All right. Okay, we're going to try. I'm going to let you guys try doing this one in your head without the formula, and then we're going to use the formula. If the blue is 10 out of 65, which is 2/13, What's the probability of getting a not blue?
55.
Try it on your own first. It's okay. All right. Anybody have it?
53.
55 out of 65. Because there's 10 blue.
Well, I'm not asking you to do the long way, just the quick way. If you don't have it yet, that's fine. We're going to do it together. 55 out of,
65.
which reduces to 11 over 13. All right, let's try the formula way. Not blue is probability, I'm sorry, it's 1 take away the probability of blue happening. Yes?
Not blue.
Not blue.
Not blue is 1 minus probability of blue.
Yep.
Right? All right, how many blues do I have? You could either use 10 out of 65 or 2 out of 13. It's up to you. 10? 2/13 will be less reducing at the end. 2/13. What would I do here? 13 over 13 or 11 over 11? Because the new denominator is 13. What's 13 take away 2? 11 over 13. Is that the same answer?
Yeah.
All right. Okay. I'm going to have you guys do number 13 on your own. Just write it down without any talking. It's easy.
100.
I did.
20. 1 out of 4.
All right. What's the answer?
80%.
Okay. Guys, you do, hey. You do not have to show all this, but I'm showing you so we know. Probability of not rain equals 1 minus the probability that it does rain. This is percent. So if I put 20%, 1 whole is how much percent? 100. What's 100%? Take away 20%.
80%.
And is that what you guys got on your own without doing all the work? Doubt it, please stop.
1 out of 4.
And 1 out of 4 is your final answer?
Yeah, that's what I got because 20% I reduced 20 divided by 100. Divided by
Oh, no, yeah, you don't want to do any dividing. It's just subtracting and that's it. All right. Listening. From 17,000 graphing calculators produced by a manufacturer, an inspector selects at random a sample of 520 calculators to see how many are defective. So did he test them all or just 520? And of those 520, how many were defective? 6. Estimate the total number of defective calculators out of this 15,000 should have been out of the 17,000. All right. Stop the talking. Now, on the previous page, nope, it didn't give us the steps. We just had to do it. So, what do we do first? Oh, you know what? It did. On the previous page, it asked first us to find the percentage and then to find out of 9,000 people. This case, it didn't ask us. Do we have to find the percentage of it, the chance of it working first?
Yes.
Okay, what's the favorable? How many are not working? Defective. How many were defective?
6.
Out of how many were tested?
520.
All right, now, guys, if I was just being asked this, I would reduce it and be done. But since they're asking me to find how many would be defective out of 17,000, I'm going to change to a decimal.
How was your last one?
0.011 is what Keith said. Do you guys agree with them? That 6 divided by 520 is 0.011.
I agree.
All right, plug it in your calculators and verify. 6 divided by 520 is 0.011. Yes or no?
Yes.
All right. Now we want to find how many of them work out of 17,000. So what do we do? Again, this was the one Giselle and Carolina gave us earlier. How do we do it? Someone besides 0.011 multiplied to what? 17,000. All right, plug that in your calculator. What do we get? So 187 calculators would be defective, yes? Questions? All right, last one. Suppose you choose a letter at random from the words shown below. What is the probability that you will not choose an M? All right, I'm going to give you guys a quick second to figure it out on your own, the quick way, then we're going to use the formula way.
9 out of 11.
Okay, I got one person say 9 out of 11. Anyone else? Agree or disagree?
No, it would, yeah.
All right, let's do it the actual mathematical way. Probability of not an M is 1 minus the probability of what? M. How many M's are there in the word mathematics? Out of how many total?
11.
So what's my 1 going to become what fraction?
11.
Is it always going to be 11 over 11? No, over here, what was it? Somewhere over here. 13 over 13, 5 over 5, depending on what your fractions are. What's 11 take away 2?
9 over 11.
And did we get the same answer that was given?
Yes.
All right, questions.
Solid. Boom.
Is it easy?
But about
All right.
pow.
Watch it get hard now.
Guys. Okay.